Welcome back, everybody. Today we're going deep on the Xen Hypervisor. Yeah! We've got a chapter from the Definitive Guide to Xen Hypervisor and some code examples to pick apart.
Nice.
So, our mission today is to really understand how this software lets you run like a whole stack of computers
Yeah.
on just one machine.
Multiple operating systems
Got it.
on one physical box.
Yeah, so it's like
It's pretty cool stuff.
virtualization.
Virtualization, exactly. And it's been around for quite a while, actually.
Oh, really?
Yeah, you can go
I
back.
thought this was kind of a newer thing.
No. Think about like the old IBM mainframes.
Okay.
Back in the 60s, they had a system called VM on their System 360.
Oh, wow.
And it let users, carve up this big, powerful mainframe into these smaller chunks,
Yeah.
each running its own operating system.
Huh. So like one building with multiple apartments.
That's a great way to think about it, yeah.
Yeah.
With different tenants in each one.
Yeah, cool. So our source material here dives into how Xen specifically does this on the by86 architecture.
Yeah, the by86.
Which is what most of our PCs
Most PCs. Yeah.
are running these days.
It's the one you're probably listening to this on right now.
Probably.
It uses by86.
And there's a bit of a wrinkle, they say, with certain by86 instructions. They call them sensitive instructions. What's the deal with those?
So these sensitive instructions are meant to interact directly with the hardware, right?
Okay.
But in a virtualized environment, you can't have all the operating systems trying to do that at the same time.
Makes sense.
Yeah, so it's
Too
like,
many cooks.
yeah, too many cooks in the kitchen.
All trying to use the same oven.
Yeah, exactly. Total chaos.
So how does X prevent this virtual kitchen meltdown?
Well, that's where the concept of paravirtualization comes in.
Okay.
So instead of letting every guest operating system directly access the hardware,
Yeah.
Xen acts as a middleman.
Okay.
So it coordinates all the requests and makes sure everything runs smoothly.
So the guests have to like place an order.
Yeah, kind of like,
Keep the head shut.
yeah, exactly. They can't just go in and grab whatever they want.
Okay.
They got to put in a request
Okay.
through a system.
How do they know what to order?
Well, that's where shared info pages come into play.
Okay.
These are like special memory areas that Xen sets up,
Uh-huh.
and they act as a kind of constantly updated bulletin board.
Okay.
So they provide all this crucial information to the guest operating systems.
So like how much memory is available?
Exactly how much memory, where to find specific resources, even things like how to keep track of the time.
Hold on, wait. How can a virtual machine know what time it is?
That's a great question.
If it's like
Yeah.
isolated from the hardware clock?
It's essentially isolated,
All
right?
right.
So Eggs uses this clever trick with what's called the timestamp counter, or TSC.
Okay.
And it's basically a counter inside the CPU
Uh-huh.
that increments with every clock cycle. And so Xen uses this counter to keep track of time and then shares that information with the guests.
But I saw in the book that this thing can sometimes like run backward.
Yes.
What's that about?
So this is one of those quirks of virtualization.
Okay.
So imagine if you're migrating a virtual machine
Mm-hmm.
from one computer to another.
Okay.
The TSC on the new machine might be ticking at a different rate,
Oh, right.
which can cause the virtual machine's clock to jump backwards.
So virtual time travel?
Yeah, in a
Is it
sense.
possible?
It's a weird thing, but it can happen.
So you can't just rely on this TSC.
Yeah, you got to be careful. And Xen has mechanisms to deal with that.
To keep everything synced up.
Exactly. Make
Yeah.
sure the clocks are all consistent.
Okay, so we've got these virtual machines. They're requesting resources. They know what time it is.
That's right.
But what about sharing? Like,
Yeah.
you got multiple virtual machines, each with their own OS and apps.
Exactly.
How do they share things like memories safely and securely?
Yeah, that's really important. You don't want them peeking into each other's data
Right.
or stepping on each other's toes.
Yeah.
Xen uses something called grant tables.
Okay.
And it's kind of like a bouncer at a club.
Right.
Each guest operating system gets its own grant table.
Mm-hmm.
And that acts as a list of permissions for accessing memory.
So like those old PO6X shared memory systems we saw in listing 4.1?
Yeah, it's a similar concept.
Processes have to request access.
Yep, you need permission to get in.
Okay, so these grant tables are like...
They're purpose-built for virtualization,
Okay.
and they provide a couple of key ways to share memory.
Okay.
You can map pages, or you can transfer pages.
What's the difference?
So mapping is kind of like sharing a Google Doc.
Okay.
Everyone who has access can see and edit it at the same time.
Okay, so that's for collaboration.
Exactly.
Okay.
Transferring is more like handing someone a copy of a document,
Okay.
and you keep your own copy.
So that's for like handing off data.
Exactly.
Okay. I'm looking at the code in listing 4.2 here.
Yeah.
And I see these commands for like manipulating these grant tables. There's even a special flag GNTMP device map
Yes.
that's used when you want to give access to an I/O device.
That's right.
Why is that important?
Well, because I/O devices need to access memory, too.
Uh-huh.
Right? You want to make sure that they only access the memory they're supposed to.
Okay.
So this flag tells Xen to work with what's called an IOMMU.
An IOMMU.
Which is like a memory traffic cop for I/O devices.
Okay.
Make sure that everything's secure and devices aren't snooping around where they shouldn't be.
Okay, so it's like a security guard for memory.
Exactly.
Okay.
Keeping things safe and sound.
So we've covered how these virtual machines request stuff. They know what time it is. They can share memory securely.
Right.
But how does Xen actually manage memory for all these different operating systems?
So Xen uses this layered approach to memory management.
Okay.
It's kind of like a 3-layer cake.
Okay. I like cake.
Yep.
Let's hear about this cake.
So the bottom layer is the physical memory.
Okay.
Right, the actual chips in your computer.
Okay, the actual hardware.
Yeah, the middle layer is what we call guest OS memory.
Okay.
And each guest operating system gets its own little chunk of this memory.
Its own little sandbox.
Exactly.
To play in.
Yep.
Okay.
And then on top, you have the application memory.
Okay.
Which is what the applications running inside the guest operating systems see.
Okay, so they don't even know.
They don't need to know about all the details.
They just see.
They just see their own little world.
Their little piece.
Exactly.
Okay.
And Xen is like the master architect, making sure that all these different sandboxes are built in the right places.
Okay.
So they don't collapse on top of each other.
So Xen uses like segmentation and paging to kind of
Exactly. It uses all those techniques
carve things up.
to manage the memory.
Okay. And I see there's a special hypercall, this hypervisor IMEXDOB,
Yeah.
that's used for like fine-tuning the memory setup.
That's right. That gives Xen really fine-grained control over the memory layout.
So it can dynamically adjust things.
Yep. Move things around as needed.
Make sure everybody has enough room.
Exactly. It's like a memory concierge,
Keeps everyone happy.
trying to optimize the layout.
Okay, this is great. But what about device drivers?
Ah, yes.
Like the software that lets the operating system talk to the hardware?
The hardware, yeah.
The hard drives, the network cards, all that stuff.
All right, so do they need to be rewritten to work in X?
Yeah, that's what I was wondering.
So Xen uses something called the split driver model.
Split driver model.
And it's a really clever way to avoid rewriting drivers from scratch.
Okay.
So instead of having one big driver
Okay.
that tries to handle everything,
Yeah.
you split it into two parts, a back end and a front end.
Oh, okay, a driver duo.
Yeah, think of it that way.
What does each part do?
So the back end runs in domain 0,
Okay.
which has direct access to the hardware.
Right.
The front end runs inside the guest operating system,
Okay.
and it talks to the back end.
So the back end's like the hardware whisperer.
Yeah, it knows how to talk to the hardware.
Okay.
And the front end is like the translator
Okay.
for the guest operating system.
Got it.
So the guest doesn't need to know all the low-level details.
Okay, so this makes it simpler to like
Yeah, it simplifies driver development a lot.
develop drivers.
And it also means you can often reuse existing drivers for the back end,
Okay, that's great.
because those drivers already exist for domain 0.
So how do these two halves of the driver communicate?
They use something called shared memory ring buffers,
Okay.
which is a really efficient way to exchange information.
So it's like a virtual courier service,
Yeah, kind of like that.
delivering messages back and forth.
Exactly.
Okay, but I saw in the book that sometimes you need these memory barriers.
Yeah.
What are those?
So memory barriers are these special instructions
Okay.
that ensure that data is written and read in the correct order.
Okay.
Because
Why would that be a problem?
well, on modern CPUs, instructions can be executed out of order,
Out of order.
which can be great for performance. But it can also cause problems when you have multiple things trying to access the same memory.
Right. So if one's writing and one's reading,
Exactly. You can get all sorts of weird behavior.
you don't want things to get jumbled up.
No, you want to make sure everything's synchronized.
Okay, so these memory barriers are like a signal,
Yeah, you can think of it that way.
making sure everything happens in the right order.
Exactly. Keeping the dance floor organized.
I like that.
Yeah.
The virtual dance floor.
It's all about the coordination,
Okay, so
making sure everything works together smoothly.
we've got requests, we've got timekeeping,
Mhm.
we've got secure memory sharing.
Right?
It's like a whole miniature society running inside our computer.
It's amazing, isn't it?
It really is.
All these different pieces working together.
But I'm curious how they communicate beyond those basic requests.
Yeah, good question.
Like, what if one virtual machine needs to send a message to another one?
Right?
Or if the hypervisor needs to signal something important to a guest.
That's where event channels come in.
Okay.
They're designed for asynchronous communication.
So they can just send a message and not have to wait for a response.
Exactly.
Okay, so it's like leaving a voicemail.
Yeah, you can think of it that way.
Okay.
You just leave a message and then you can go on about your business.
So it's all about efficiency.
Exactly, making things fast and responsive.
Okay, but I was looking at the chapter and it talked about different types of event channels.
Right.
There's interdomain events and physical IRQs and virtual IRQs.
Yep, lots of different flavors.
What are the differences?
So interdomain events are for communication between different guest operating systems.
Okay.
So it's like having a direct line between those virtual apartments we talked about earlier.
Okay.
Physical IRQs are used to connect real hardware interrupts.
Okay, like a key press or a mouse click.
Exactly, to the event channels.
So the guest operating system can still interact with the outside world.
That's right.
Okay, and what about virtual IRQs?
Those are for communication within the virtual environment.
Okay, so like between the front end and back end of a drive, right?
Exactly.
Okay, cool. And listing 7.3 shows an example of binding the timer virtual interrupt to an event channel.
Right.
What's that all about?
So you can think of it like setting an alarm clock in a virtual machine.
Okay.
The hypervisor sets the alarm, and when it goes off, it sends a notification through the event channel.
Okay, so the guest operating system doesn't have to constantly check the clock.
Exactly. It just gets notified when the time is up.
Makes sense. Very efficient.
That's the idea.
Okay, so we've talked about requests, memory sharing events. What about configuration?
Ah, yes, configuration.
Like if you have a whole bunch of virtual machines running,
Right.
how do you keep track of all the settings
Right.
and make sure everyone's on the same page?
That's where the XenStore comes in.
The XenStore? Okay, what is that?
It's basically a central registry office for the whole virtual environment.
Okay.
It's a place where different domains, including the guest operating systems, can store and retrieve information.
Okay.
And it uses a hierarchical structure, kind of like a file system.
Okay, so it's more than just a store. It's like a place where virtual machines can go to find out about each other.
Exactly. They can
Okay.
learn about the available resources, the network configuration, all that stuff.
Listing 8.1 shows a cool parallel between the XenStore and those POCX shared memory functions we talked about earlier. So
Yeah.
it's the same idea.
Yeah, it's a similar concept, but applied to a different problem.
Controlled access to information.
Exactly, whether it's memory or configuration data.
Okay, this is all really cool.
Yeah.
So we've got event channels for real-time communication.
Right.
We've got the XenStore for sharing information and configuration.
Yeah.
All these clever mechanisms for managing resources.
Because it's a pretty amazing piece of software.
It is, but what about the future?
Ah, the future.
Our source material mentions something called hardware virtualization, or HVM.
Yes, HVM.
How does that fit into all of this?
So hardware virtualization is a game changer.
Yeah.
Remember those sensitive x86 instructions that made paravirtualization necessary?
Yeah.
Well, newer processors
Okay.
actually include special hardware features that address those issues.
Oh, wow.
So with HVM, you can run unmodified operating systems,
Okay.
like the ones you'd install on a regular PC,
Right.
directly on Xen, without any special modifications.
So does this mean paravirtualization is going away?
Not necessarily.
Okay.
Paravirtualization still has some performance advantages,
Okay.
especially for things like device driver communication and memory management.
Okay.
So we'll likely see a hybrid approach in the future.
Okay, so combining the best of both worlds.
Exactly.
Okay, cool. So Xen's constantly adapting and evolving.
It has to keep up with the ever-changing world of technology.
Right.
But before we get too far ahead of ourselves,
Yeah.
I think it's worth taking a moment to appreciate what we've learned so far
I agree.
about this incredible piece of software.
Yeah, it's a testament to the ingenuity of the people who designed it.
It really is. They had to overcome some really tough challenges.
Absolutely. And for our listeners who are just dipping their toes into the world of virtualization, what would you say are the key takeaways so far?
So I'd say, first, virtualization is more than just a technical curiosity.
Okay.
It's a fundamental shift in how we think about computing.
Okay.
It lets us break free from the constraints of physical hardware
Right.
and create these flexible, adaptable environments
Right.
that can meet a whole range of needs.
Okay.
Second, Xen is a great example of how software can bridge that gap between complex hardware
Okay.
and the needs of users.
Yeah.
It gives us the power to create and manage these virtual machines
Okay.
with incredible precision.
Okay.
And finally, the world of virtualization is constantly changing,
Yeah.
New technologies are emerging.
Right.
And Xen's at the forefront of that evolution.
Okay.
Constantly adapting.
Well said.
Thank you.
So where do you see Xen heading in the next few years?
Ooh, that's a great question.
What are some of the exciting areas of innovation that you're looking at?
Well, one area that I think is really ripe for innovation is scheduling.
Scheduling.
Yeah, so right now, Xen uses different algorithms
Yeah.
to decide which virtual machine gets to use the CPU at any given times.
Yeah.
But as the tasks we ask our computers to do become more complex, those algorithms will need to adapt.
So it's not just about being fair. It's about
more than just fairness.
making sure everything runs smoothly.
Exactly.
Especially with all these different applications.
Right. Different applications have different needs.
Right. Some are more time sensitive than others.
Exactly. And the scheduler needs to take all of that into account.
So like a server running virtual machines that are handling like website traffic and number crunching and video conferencing.
Yeah, exactly.
That scheduler has a lot on its plate.
It's a tough job.
And our book mentions some interesting concepts like borrowed virtual time.
Yes. Borrowed virtual time.
And work-conserving schedulers.
Work-conserving schedulers, right?
Can you unpack those a little bit for us?
Sure. So borrowed virtual time is kind of like an advance on CPU time.
Okay.
So if a virtual machine needs a quick burst of processing power,
Yeah.
even if it hasn't technically earned it yet,
Uh-huh.
the scheduler can give it a little boost.
Okay.
As long as it repays that time later.
So it's like a microloan.
Yeah, exactly. A microloan for CPU cycles.
I like that. And what about these work-conserving schedulers?
Those are all about efficiency.
Okay.
So a work-conserving scheduler will always try to keep the CPU busy.
Okay.
If there's a virtual machine ready to run, it'll get the CPU right away.
Instead of just letting those processing cycles go to waste?
Exactly.
So it's like making sure every minute of the workday is productive.
That's a good way to think about it.
Okay, cool. But scheduling is not the only area where we might see big changes.
Right.
What about security?
Yeah, with all these virtual machines sharing resources,
Yeah,
security has to be a top priority.
absolutely. And that's where features like IMUs become even more important. Right, we talked about those.
Right, they act like security guards for memory,
Yeah,
making sure that I/O devices don't access anything they shouldn't.
right. And as hardware virtualization becomes more common,
Yeah.
those IOMUs can work hand in hand with the built-in security features of the hardware.
Exactly.
So it's like multiple layers of security,
Right.
each one reinforcing the others.
Exactly. It's all about creating a really robust and secure environment.
Right, where these virtual machines can thrive.
Yeah, without stepping on each other's toes or letting in any unwanted guests.
Speaking of layers,
Yes.
one of the things that's always fascinated me about Xen is this whole layered architecture. Right, we talked about domain zero, that privileged domain.
Yeah, the one with all the special access.
But the chapter hints at this idea of domain zero devolution.
Ah, yes, devolution.
Huh, what's that all about?
So it's basically about spreading the responsibility.
Okay.
Instead of having everything centralized in domain zero,
Right.
what if we could move some of those tasks to other domains, each specializing in a particular area?
So instead of having one all-powerful ruler,
Yeah,
we have more of a distributed system.
exactly. More like a democracy.
Okay, so this could actually make the system more efficient.
It could, because you'd have these specialized domains.
Right.
For things like networking or storage or security.
Each one optimized for its particular role.
Exactly.
Okay, cool. So the future of S is about flexibility, specialization, and efficiency.
Those are some of the key themes.
But with all these advancements, there must be some challenges as well.
Oh, definitely.
What are some of the hurdles that Xen might face as it continues to evolve?
So one of the biggest challenges, I think, is managing complexity.
Complexity.
Yeah. As Xen gains new features and adapts to new technologies,
Mm-hmm.
the code base inevitably grows
Right.
larger, more intricate.
Okay.
So maintaining code quality,
Yeah.
ensuring security,
Yeah.
making it easy for developers to work with.
Right.
These are all ongoing challenges.
And with hardware changing so quickly,
Oh, yeah. The hardware landscape is constantly evolving.
Xen has to keep up.
It does. It's a constant race to stay ahead of the curve.
Imagine a system with a traditional CPU, a powerful GPU, and even specialized processors for things like AI.
Yeah, or cryptography.
Xen needs to manage all these different resources.
It needs to be able to handle all these different types of hardware.
So the future of Xen is not just about virtualization.
No, it's about something bigger.
It's about orchestrating a whole symphony of hardware resources.
That's a great way to put it.
Okay, so for our listeners who are just getting started with this, what are the key takeaways from today's deep dive?
So I'd say first, virtualization is a game changer.
Okay.
It lets us think about computing in a whole new way,
Right.
breaking free from the limitations of physical hardware.
Okay.
Xen is a powerful example of how software can make that vision a reality,
Okay.
providing the tools to create and manage these virtual machines.
Okay.
And as we've seen, Xen isn't standing still.
Right.
It's constantly evolving, embracing new technologies,
Right.
adapting to the ever-changing landscape of computing.
It is. And the future of Xen is bright. It's full of exciting possibilities.
Yeah.
And for anyone who wants to learn more, I highly recommend checking out the source material.
Yes, definitely.
Especially the code examples.
There's no better way to really understand how X works.
Than to see the code itself.
Exactly.
So the world of virtualization is full of fascinating challenges.
It is.
And opportunities.
It's a really exciting field to be in.
Who knows, maybe one of our listeners will develop the next groundbreaking feature for S.
I hope so.
Or build the next amazing virtualized application.
That would be fantastic.
The possibilities are endless.
They really are.
So keep learning. Keep exploring.
Keep pushing the boundaries.
And keep those CPUs humming.
And those virtual machines running smoothly.
Thanks for joining us.
It was a pleasure being here.
We'll be back soon with another deep dive into cutting-edge technology.
Looking forward to it.
Until then, keep those CPUs humming.
And those virtual machines running.
We'll see you next time.
Yeah.
So we've got these requests, we've got timekeeping, we've got secure memory sharing. It's like this whole miniature society running inside our computer.
Yeah. It's amazing how it all comes together.
It really is. But I'm wondering, how do they communicate beyond those basic requests?
Right. Like, how do they send messages to each other?
Yeah. What if one virtual machine needs to talk to another one?
Right.
Or if the hypervisor needs to signal something?
That's where event channels come into play.
Okay.
They're like these little communication pathways.
Okay.
Designed for asynchronous communication.
Okay. So it's a way for them to send a message.
Right.
And not have to wait for a response.
Exactly. It's like dropping a note in a mailbox.
Okay.
You don't have to wait around for the person to pick it up.
So they can get on with other tasks.
Exactly.
Okay. So it's all about speed and efficiency.
It is.
Okay. But I was reading through the chapter and it mentions different types of event channels, like interdomain events and physical IRQs and virtual IRQs.
Yep, there are a few different flavors.
What are the differences?
So interdomain events are specifically for communication between guest operating systems.
Okay, so that's like a direct line.
Yeah, like a private phone line between those virtual apartments
we
were talking about.
I got it. And what about physical IRQs?
Physical IRQs are a way to connect those real hardware interrupts.
Okay.
Like from your keyboard or your mouse to the event channels so that the guest operating systems can respond to them.
Okay, so the virtual machine still has a way to interact with the outside world.
Right, even though it's running in this virtual environment.
Cool. And what about virtual IRQs?
So those are for communication within the virtual environment itself.
Okay.
Like between the front and back end of a device driver.
Okay, so like internal communication.
Exactly.
Okay. And listing 7.3 shows an example of binding the timer virtual interrupt to an event channel.
Yes.
What does that mean?
Think of it like setting an alarm clock in a virtual machine.
Okay.
The hypervisor sets the alarm, and when it goes off, it sends a notification through the event channel to wake up the guest operating system.
So it doesn't have to keep checking the clock.
Exactly. It just gets a notification when the time is up.
So we've got requests memory sharing events. What about configuration?
Ah, yes. Configuration. That's important too.
Yeah, like if you've got a whole bunch of virtual machines running,
right?
How do you keep track of all the settings and make sure everyone's on the same page?
Well, that's where the XenStore comes in.
The XenStore, what is that?
Think of it like a central bulletin board for the entire virtual environment.
Okay.
It's a place where different domains, including the guest operating systems, can store and retrieve information.
Okay.
It uses a hierarchical structure, kind of like a file system.
Okay, so it's more than just a store. It's a place where virtual machines can go to find out about each other.
Exactly. They can learn about available resources, network configuration, all sorts of stuff.
Okay, and listing 8.1 shows an interesting parallel between the XenStore and those P06 shared memory functions we were talking about.
Yeah, it's a similar concept, but applied to a different problem.
Right, it's all about controlled access to information.
Exactly, whether it's memory or configuration data.
Okay, so we've got these event channels for real-time communication. We've got the XenStore for this shared information configuration.
Right.
All these clever mechanisms for managing resources.
X's is a pretty amazing piece of software.
It really is. But what about the future?
Ah, the future always exciting.
The chapter mentions this thing called hardware virtualization, or HVM.
Yes, HVM.
How does that fit in with everything we've been talking about?
So hardware virtualization is a game changer.
Okay.
Remember those sensitive by 86 instructions
Yeah.
we talked about earlier?
Yeah, the ones that made paravirtualization necessary?
Exactly. Well, newer processors from AMD and Intel
Okay.
actually include special hardware features that address those issues.
Oh, wow.
So with HVM, you can run unmodified operating systems.
Like the ones you'd install on a regular computer.
Exactly.
Directly on Xen, without any modifications.
That's the beauty of it.
So does that mean paravirtualization is going away?
Not necessarily.
Okay.
Paravirtualization still has some performance advantages,
Okay.
especially for things like device driver communication and memory management.
Okay.
So we'll likely see a hybrid approach in the future.
Combining the best of both worlds.
Exactly, taking advantage of the strengths of each approach.
Okay, cool. So Xen is constantly adapting and evolving.
It has to keep up with the ever-changing landscape of technology.
Right.
But before we get too far ahead of ourselves,
Yeah.
I think it's worth taking a moment to appreciate what we've learned
I agree.
about this incredible piece of software.
It's a testament to the people who designed it.
It really is. They had to overcome some really difficult challenges.
And for anyone listening who's just getting started with virtualization, what would you say are the key takeaways?
I'd say first, virtualization is more than just a technical curiosity. It's a fundamental shift in how we think about computing.
Right.
We can break free from the constraints of physical hardware,
Okay.
create these flexible, adaptable environments that can meet a wide range of needs.
Okay.
Second, Xen is a great example of how software can bridge that gap between complex hardware
Okay.
and the needs of users.
Right.
It gives us the power to create and manage these virtual machines with amazing precision.
Right.
And finally, the world of virtualization is constantly changing. New technologies are emerging.
Yeah.
And Xen is right at the forefront, constantly adapting to this changing landscape.
Well said.
Thank you.
So where do you see Xen heading in the next few years?
Oh, that's a big question.
What are some of the exciting areas you're looking at?
Well, one area I think is ripe for innovation is scheduling.
Scheduling.
Yeah. So right now, Xen uses different algorithms to decide which virtual machine gets to use the CPU at any given time.
Right.
But as the tasks we're asking our computers to do become more and more complex,
Yeah.
those algorithms will need to adapt.
So it's not just about being fair, it's about...
It's about more than fairness. It's about making sure that everything runs smoothly.
Yeah, especially when you've got all these different applications running.
Exactly. Different applications have different needs. Some are more time sensitive than others.
Right.
And the scheduler has to take all of that into account.
So like a server that's running virtual machines that are handling website traffic and number crunching and video conferencing all at the same time.
Exactly. It's a lot to juggle.
And the book mentions some interesting things like borrowed virtual time.
Yes, borrowed virtual time.
And work-conserving schedulers.
Work-conserving schedulers.
Can you kind of unpack those for us a bit?
Sure. So borrowed virtual time, you can think of it like an advance on CPU time.
Okay.
So if a virtual machine needs a quick burst of processing power, even if it hasn't technically earned it yet, the scheduler can give it a little boost as long as it repays that time later.
So it's like a microloan for CPU cycles?
Exactly, a microloan for CPU cycles.
I like that. And what about work-conserving schedulers?
Work-conserving schedulers are all about efficiency.
Okay.
So if there's a virtual machine ready to run, it'll get the CPU right away instead of letting those processing cycles go to waste.
So making the most of every minute.
Exactly.
Okay, cool. But scheduling isn't the only area where we might see big changes.
Right, what about security?
Yeah, with all these virtual machines sharing resources, security has to be a top priority.
Absolutely. And that's where things like IOMUs become even more critical.
Right, we talked about those earlier.
Right, they act as the security guards for memory, making sure that I/O devices don't access memory they shouldn't be accessing.
And as hardware virtualization becomes more common, those IMUs can work hand in hand with the hardware.
Exactly. You get multiple layers of security, each one reinforcing the others.
So it's like a defense in depth approach to security.
Exactly.
Okay, cool. One of the things that always fascinated me about Xen is its layered architecture. We've talked about domain 0, that special privileged domain, but the chapter mentions this idea of domain 0 devolution.
Yes, devolution.
What's that all about?
So the idea is to spread the responsibility instead of having everything centralized in domain 0.
Okay.
What if you could move some of those tasks to other domains that specialize in particular areas?
So instead of having one all-powerful ruler,
Yeah.
you have more of a distributed system.
Right, more like a democracy.
Okay, and this could make the system more efficient.
It could, because you would have these specialized domains for things like networking, storage, or security,
Okay.
each one optimized for its particular role.
Okay, so the future of Xen is about flexibility, specialization, and efficiency.
I think those are some of the key themes, yeah.
But with all these advancements, there must be some challenges as well.
Oh, there are definitely challenges.
What are some of the hurdles that Xen might face as it continues to evolve?
One of the biggest challenges, I think, is managing complexity.
Complexity.
As Xen gains new features and adapts to new technologies, the code base inevitably grows larger and more intricate. So maintaining code quality, ensuring security, making it easy for developers to work with.
Right.
Those are all ongoing challenges.
But with hardware changing so rapidly.
Oh yeah, the hardware landscape is constantly shifting.
Xen has to keep up with all the new processors and accelerators and all those things.
It does. It's a constant race to stay ahead of the curve.
Right. Like imagine a system with a traditional CPU, a powerful GPU, and then maybe specialized processors for things like AI or cryptography.
Yeah.
Xen needs to be able to manage all these different resources effectively.
It does. It's a very complex problem.
So the future of Xen isn't just about virtualization, it's about orchestrating all these different hardware resources.
That's a great way to put it.
Okay, so for listeners who are just starting out with Xen and virtualization, what are the key takeaways from our deep dive?
I'd say first, virtualization is a game changer.
Okay.
It lets us think about computing in a completely different way,
Right.
breaking free from the limitations of physical hardware. Xen is a powerful example of how software can make that vision a reality.
Okay.
It provides the tools and mechanisms to create and manage these virtual machines with incredible flexibility and control.
And Ez isn't standing still.
No, it's not.
It's constantly evolving, embracing new technologies, and adapting to the changing landscape of computing.
Exactly. It's a very dynamic field.
Absolutely. And the future of Xen is bright.
It is.
Full of exciting possibilities.
Definitely.
And for anyone who wants to learn more, I highly recommend checking out the source material.
Yes, especially those code examples.
Yeah, there's no better way to really understand how Xen works than to see the code itself.
I completely agree.
So the world of virtualization is full of fascinating challenges and opportunities.
It is. It's a great field to be in.
Who knows, maybe one of our listeners will develop the next groundbreaking feature for Xen.
That would be amazing.
Or build the next amazing virtualized application.
I hope so.
The possibilities are endless.
They really are.
So keep learning, keep exploring.
Keep pushing the boundaries.
And keep those CPUs humming.
And those virtual machines running smoothly.
Thanks for joining us.
It was a pleasure being here.
We'll be back soon with another deep dive into cutting-edge technology.
Looking forward to it.
Until then, keep those CPUs humming.
And those virtual machines running.
We'll see you next time.
See you later. One area I think is really ripe for innovation is scheduling.
Scheduling.
Yeah. So right now, Xen uses these different algorithms, to decide which virtual machine gets to use the CPU at any given time.
Okay.
But as the tasks that we're asking our computers to do, they become more complex.
Right.
Those algorithms are going to need to adapt.
So it's not just about being fair, it's about...
It's about more than fairness.
Right.
It's about making sure that everything runs smoothly,
Especially when you have, all these different applications running.
Exactly. And all the different applications have different needs.
Right.
Some are more time sensitive than others.
Yeah.
The scheduler has to take all that into account. Yeah.
So like a server running virtual machines that are handling like website traffic and number crunching and video conferencing.
All at the same time, yeah.
It's a lot to juggle.
It's a tough job for sure.
And the chapter mentions some interesting concepts like borrowed virtual time.
Yeah, borrowed virtual time. That's a good one.
And work-conserving schedulers.
Work-conserving schedulers.
Can you unpack those a little bit for us?
Sure. So borrowed virtual time, you can think of it kind of like an advance on CPU time.
Okay.
So if a virtual machine needs, a really quick burst of processing power.
Yeah.
Even if it hasn't technically earned it yet, you see,
right.
Scheduler can give it this little boost.
Okay.
As long as it repays that time later on.
So it's like a microloan?
Exactly. A microloan for CPU cycles.
I like that analogy.
Yeah.
What about these work-conserving schedulers?
So, work-conserving schedulers are all about efficiency.
Okay.
So they will always try to keep that CPU busy.
Okay.
If there's a virtual machine that is ready to run, it's going to get the CPU right away.
Instead of letting those processing cycles.
Instead of wasting those cycles.
Exactly. Sitting there idle.
Make the most of every minute.
Oh, okay, cool. But scheduling isn't the only area where we might see some big changes in the future.
What about security?
Yeah, with all these virtual machines,
Right.
sharing resources, security has to be a top priority.
Security is always a top priority.
Right.
And that's where things like these IOMUs that we talked about,
Right.
they become even more critical, I think.
Right. We talked about those earlier.
Right.
Acting as like a security guard for the memory.
Right. They make sure that the IO devices don't access any memory they shouldn't be accessing.
Right. And as hardware virtualization becomes more common,
Right.
those IOMUs can work hand in hand with the hardware itself.
Yeah, you get this really nice synergy
Right.
between the hardware and the software.
So it's like this, like a defense in depth approach.
Exactly. Multiple layers of security.
Okay, cool. One of the things that has always fascinated me about Xen is its layered architecture.
Yeah, it's a very elegant design.
Right. We've talked about domain zero, this like privileged domain that has this, special access. But the chapter mentions this idea of domain zero devolution.
Ah, yes, devolution.
What is that?
So the idea is basically to spread the responsibility around,
Right.
Instead of having everything centralized in domain zero,
Right.
what if you could move some of those tasks to other domains
Okay.
that specialize in particular areas?
So instead of one, all-powerful ruler,
Right.
it's more of a distributed system.
Exactly, more like a democracy.
Okay. And that could make the system more efficient.
It could, because you would have these specialized domains,
Right.
for things like networking
Right.
or storage or security.
Each one's really good at its one job.
Exactly, optimized for its particular role.
Okay, so the future of Xen is all about, flexibility, specialization, efficiency.
Yeah, those are some of the key themes for sure.
But with all these advancements, there must be some challenges too.
Oh, definitely. There are always challenges.
What are some of the hurdles that you think Xen might face as it continues to evolve?
Well, I think one of the biggest challenges is managing complexity. As Xen gains all these new features
Right.
and adapts to all these new technologies,
Right.
the code base, inevitably grows larger, more intricate.
Right.
So how do you maintain that code quality? How do you make sure it's secure?
Yeah.
How do you make sure that it's easy for developers to work with?
Right.
These are all these ongoing challenges.
And with the hardware changing so quickly,
The hardware landscape is constantly shifting.
Xen has to keep up with all the new processors and accelerators and all these things.
With a constant race to stay ahead of the curve.
Right. Like, imagine a system with a traditional CPU,
Yeah.
a powerful GPU, and then maybe some specialized processors
Yeah.
for like AI workloads or cryptography.
Right.
Xen needs to be able to manage all those different resources.
It's a really challenging problem.
So the future of Xen isn't just about virtualization. It's about orchestrating all these different hardware resources.
It's about creating this platform
right.
that can handle all these different types of hardware
Yeah.
and make them all work together seamlessly.
Okay, so for our listeners who are, maybe just getting started with Xen in virtualization, what are the key takeaways from our deep dive?
So I'd say, first, virtualization is a game changer.
Okay.
It lets us think about computing in a completely different way,
Right.
breaking free from the limitations of, all this physical hardware.
Okay.
X is a powerful example of how software can make that vision a reality.
Okay.
It provides the tools and the mechanisms to create and manage these virtual machines
Right.
with just incredible flexibility and control.
And Xen isn't standing still.
No, it is constantly evolving.
Right. Embracing new technologies, adapting to this changing landscape of computing.
It's a very dynamic field.
Absolutely. And the future of Xen is bright.
It is.
It's full of all these exciting possibilities.
The possibilities are endless.
And for anyone who wants to learn more, check out the source material,
Yes, definitely.
especially those code examples.
The code examples are the best way to really see how it all works.
Right. You can see all the nuts and bolts.
Exactly.
So the world of virtualization,
It's a fascinating world.
it's full of these fascinating challenges
It is.
and opportunities.
Yeah.
Who knows, maybe one of our listeners will develop the next groundbreaking feature for Xen
That'd be awesome.
or build the next amazing virtualized application.
Yeah,
The possibilities are truly endless.
they really are.
So keep learning,
Keep learning,
keep exploring,
keep exploring,
and keep those CPUs humming.
and those virtual machines running smoothly.
Thanks for joining us.
It was a pleasure being here.
We'll be back soon with another deep dive into cutting-edge technology.
Until next time.
Until next time, keep those CPUs humming.
And those virtual machines running smoothly.
We'll see you then.